Okay, everyone. So let's start limit continuity. First, I will talk about limit. So let us start with a formal definition of limit that is given by Wursters, a famous mathematician. The function fx is said to tend to the limit L and x tends to a if given a positive number epsilon, there exists a positive number delta such that modulus of fx minus L less than epsilon for every x satisfying the inequality 0 less than mod x minus L less than delta. Or let fx be defined on an open interval about a except possibly at a itself. If fx gets desirably close to L as x becomes sufficiently close to a, we say that f approaches to the limit L as x approaches a, and we write limit x tends to a fx equal to L. So that is according to the definition, but I will show some diagram. First of all, I will explain what do you mean by x tends to a. X tends to a point A means a real point. X approaches A from the left as well as from the right, taking very small values, very close to A. That means very close to A, but not necessarily equal to A. So that is the meaning of x tends to A. Now, what is the functional concept? Functional concept is this: limit x tends to a fx equal to L. So this is the famous epsilon delta definition. Maybe it looks very complicated, but let me explain in a diagram. Yeah, so let's have a axis, x axis, and this is y axis, and this is the curve y equal to fx. So for x equal to a, this is the point A, and take a very small neighborhood of a minus delta, a plus delta. It's a very small neighborhood of a, and the corresponding neighborhood of the point. So for a, suppose the value of the function is L. So you have a very small neighborhood of L, that is L minus epsilon and L plus epsilon. Okay. So for let f be a function. You see the graph. Let f be a function defined on an open interval containing a except possibly at a, and let L be a real number, and L limit x tends to a. It is given that limit x tends to a fx equal L. So means that for each real epsilon greater than 0, for each epsilon greater than 0, there exists a real number delta greater than 0, delta. You see delta here in the graph on the x axis, such that for all x in lies between this open interval a minus delta comma a plus delta, that is for all x satisfying the inequality x minus a less than delta, that's denote this interval. Actually we have mod fx minus L, we have mod fx minus L less than epsilon, less than epsilon. So for each epsilon greater than 0, there exists a delta greater than 0 and all the values of x lies in the interval, implies that all the values of fx will lies in this interval, that is L minus epsilon. This implies actually L minus epsilon less than fx less than L plus epsilon. Then we say limit x tends to a fx equal to L. So that is the epsilon delta definition of limit. If I want to explain in another way, this is the graphical demonstration. Let me explain in the another way. Let me try to explain. This is the neighborhood of x. So this is x and this is the neighborhood of fx. Y equal to fx function. Okay, and this is L. So naturally this will be L minus epsilon. For each epsilon greater than 0, there exists a delta greater than 0. Here you have a delta greater than 0. So a minus delta, a minus a plus delta will be another interval. Okay, now suppose x is approaching towards a from the left. So naturally there will be a point on the left of L. So function is also approaching towards L from the left. More closer, you will get more closer here. More closer to A, but not necessarily A. So you are approaching from the left to more close to L. Again from the right, if you are at the right of, if you are at the right of A, you are approaching towards A from the right. For the right end point, you are having a point on the right. More closer to A, the point, the function will get closer to L also. So this is the concept of limit. So that is mathematically written as x tends to a, as x tends to a, fx tends to L, as x tends to a, fx tends to L, and we write limit x tends to a, fx equal to L. That is the concept of limit, and that is the definition according to the definition of limit. Okay, now I will have some practical example. Find limit x tends to a, x squared minus 4 by x minus 2. Let us have this example. So in this example you see as x not equal to 2, x minus 2 not equal to 0, because x tends to 2 implies x is approaching 2 towards from the left as well as from the right. So limit x tends to 2, you can factorize the numerator x minus 2 times x plus 2. X minus 2 get cancelled because x is not equal to 2, x minus 2 not equal to 0. Now suppose from the this is your 2 point, so you are very close to 2, that is suppose 1.9. so what is your fx will be 3.9. again suppose 1.9, that is 99, that is closer to 2, more closer, you get closer, you look at the values of x and fx would be closer to 4. So this is 3.9, 3.99. So you are moving towards 4 also. Fx is also moving towards 4, 4 from the right, from the left. You can see the same thing from the right also. You can see the same thing from the right. You see, if x is approaching from the right, x is approaching from the right, taking very close, very small values, 2.1, 2.01, 2.0001. So you are approaching from the right. Fx is also approaching towards 4, taking very small value. It's in the neighborhood. So look at the values. So this is experimentally you can see here as x approaches to 2 from left hand side, value of fx is getting closer and closer to 4. Again, as x approaches to 2 from right hand side, value of fx is getting closer and closer to 4. Further, we can make the values of fx as close to 4 as we like by choosing values of x sufficiently close to 2. Therefore, we say in this in the previous case we say limit x tends to limit x tends to 2 minus fx, 2 suffix minus, that is actually that power is minus, that denotes the left hand side. You are approaching from left hand side, so it is the notation of left hand side approach, 2 minus, and in this case you have 2 plus, so it implies you are approaching from the right, 2 plus, from the right of 2, from the left hand to 2 minus. If these two limit exist and equal, if these two limit exist only when left hand limit and right hand limit approaches to the same finite value, then we say the limit exists. That is the main condition or criteria for existence of limit. That is, left hand limit must be equal to the right hand limit. Left hand limit at that point, that is here the point is limit x tends to 2 minus, minus means its power is minus, that denotes you are approaching from left, that must be equal to the right hand limit. What is right hand limit? That is limit x tends to 2 plus fx, that is you are approaching from the right towards 2. That is why if these two limits are equal, and then we say the limit exists, and finally we say limit x tends to 2 fx equal to 4. That is the condition existence criteria for the limit. Okay, so here you have an example that left hand limit not equal to right hand limit, so limit x tends to 2 fx does not exist. Let's see the example. You see, fx is x plus 2 if x less than 2, and if x is 4.001 if x is greater than 2, then find limit x tends to fx, x tends to 2 fx. So for x equal to 2.01, that is from right, you are taking from the right, so you see your fx will be 4.0001, and from the left you will see your fx will be 4. If you are approaching from left, your fx is approaching towards 4, so limit x tends to 2 minus fx equal to 4, but your right hand limit is 4.001, so left hand limit not equal to right hand limit, hence limit x tends to 2 fx doesn't exist. Okay, let's have another example. So okay, already we have discussed, and this is the this is the diagram. You see the diagram here, and in this case you see your left hand limit and right hand limit are equal, so there is no jump actually. But in this, in the second diagram, in the second example, you see your left hand limit is this one and your right hand limit is this one, so there is a gap, so this is discontinuous actually. I will explain later on what is continuity, but you see that you can see the discontinuity, so the limit does not exist because left hand limit has a different value 4 and right hand limit has a value different value, so left hand limit not equal to right hand limit, limit does not exist. Okay, I will explain one more example for you guys. So let me give you an example. Suppose fx equal to mod x over x, and x is not equal to 0 definitely, otherwise the function is not defined at 0, so x not equal to 0, and you know that mod x is x when x is, so it will be 1 if x is positive, because mod x is x, so x get cancelled because x is not equal to 0, and it will be -1 if x less than 0, so x mod x is minus x by x, that is -1, so 1 and -1. Okay, so 1 and -1, so let's check the limit. So what is your left hand limit? Left hand limit, the point is 0, so left hand limit is, you can see clearly it is -1, and right hand limit is 0 plus fx, that is equal to 1. Okay, so we can draw the diagram. So this is the point. This is the line y equal to 1, and this is the line y equal to -1. See, your left hand limit is -1 and right hand limit is 1. So there is a jump discontinuity. There is a jump between these two values. There is a gap, big gap. So this is discontinuous and the limit does not exist because your left hand limit not equal to right hand limit. Okay. So I will explain different properties after that. Intermediate forms. Okay, let me have indeterminate forms. So you see, if your fx will be of the form, if your limit will be of the form 0 by 0 or infinity by infinity, suppose x square minus 4 by x minus 2, that is of the form 0 by 0 because the numerator tends to 0 whenever x tends to 2 and the denominator tends to 0 whenever x tends to 2. So that is 0 by 0 form, and this is infinity by infinity form because log x tends to infinity and x tends to infinity. This is infinity by infinity form. So these are all indeterminate forms. And limit x tends to 0, 1 plus x whole to the power 1 by x, that is also indeterminate form because it's 1 to the power infinity. X equal to 0 will give you 1 to the power infinity, that is also indeterminate form. So there are ways to calculate this type of problems I will discuss. And there are also many indeterminate forms also. Let us have some properties of limits. If limit x tends to a fx equal to L and limit x tends to a gx equal to m, then the sum rule is limit x tends to a fx plus gx equal to L plus m, and the difference rule is limit x tends to a fx minus gx, you can split the limits L minus m. Okay, product rule, fx times gx you can separate and you can write limit x tends to fx into limit x tends to gx, that is L into m. Constant multiple rule, limit x tends to a k fx, that is k into limit x tends to fx, that is L, k into L. Quotient rule, limit x tends to a fx by gx, that is equal to L by m, m not equal to 0. And there is a power rule also, rule for composite function. This is important one. Why this is important? Because there will be some composite functions in your calculation. So limit x tends to a f of gx, some composite function, composition of functions. So f of limit x tends to a gx equal to fm because limit x tends to a gx is m, provided f is continuous at m, provided f is continuous at m. This is very very important. If f is not continuous, you cannot do that. This is the only restriction. And there will be some standard limits. If fx tends to 0 when x tends to a, sine of limit x tends to a, sine of fx by fx equal to 1. And in the special case it will be sine x by x limit x tends to 0, it is the particular case, equal to 1. There are some standard limits. So limit x tends to a fx sin fx by a function of x equal to 1, limit x tends to a cos fx equal to 1, limit x tends to a tan fx by fx equal to 1, limit x tends to a e to the power fx minus 1 by fx equal to 1, and limit x tends to a b to the power fx minus 1 by fx equal to log b ln b, and this is equal to 1. Also I can write limit x tends to 0. These are the particular cases. This is the standard limits also. Tan x by x equal to 1. Also we can write limit x tends to 0 e to the power x minus 1 by x equal to 1. Also we can write limit x tends to 0 ln log base e ln 1 plus x by x equal to 1. So these are all standard limits. These are all standard limits. You see, I have explained this. These are all standard limits. So these are the above results. These are the results I have explained. I will explain some problems. Before that, uh, let me give you some series expansion if you need. Yeah, expansions of binomial, exponential, logarithm, expansion of sine, cos, tan, etc. These are all expansions from Taylor series expansion. Taylor series is a mean value theorem, nth order mean value theorem. Actually, that is the mean value theorem for nth order differentials. So smooth functions. So these are all expansions from Taylor series expansion. So what is the expansion of a to the power x? 1 plus x ln a by factorial 1, x square ln square a by factorial 2, etc. What is the expansion of e to the power x? 1 plus x by factorial 1 plus x square by factorial 2 plus etc. What is the expansion of ln 1 plus x? That is x minus x square by factor 2 plus x cube by 3, etc. Provided that minus 1 less than x less than equal to 1. And what is the expansion of sine x? It's odd power all. All are from odd power. Look at that, x to the power 1 minus x cube by factorial 3 plus x to the power 5 by factorial 5 minus x to the power 7 by factorial 7, etc. What is cos x? Cos x all are even power. X to the power 0 minus x squared by factorial 2 plus x to the power 4 by factorial 4 minus x to the power 6 by factorial 6 plus etc. What is tan to the power x? Tan x. Tan x is x plus x cube by 3 plus 2x to the power 5 by 15, etc. Tan inverse x, sine inverse x, sec inverse x. But these are important. Sine, cos, it exponential, log. These are all useful expansions. I will explain in the problems. Okay, and these expansions actually required for JEE mains and advanced, not for your boards. These are specially for your JEE mains advanced exams. Okay.